Hi everyone. Today we're going to be talking about systems of equations, particularly graphing. Now we need to remember that a solution to systems of equations is one amount for x and y that will solve both equations. So right now we have the problem, find the solution to 2x plus 2y equals 6 and 4x plus 6y equals 12. What we need to do is find one value for x and one value for y that will solve both of those solutions. And the strategy we're going to be using right now is graphing. We'll be using elimination and substitution in another video. So here we go. Step 1. Step 1 is to convert equations from standard form to slope-intercept form. If it is already in slope-intercept form, then you can move on to step 2. But in this case, we don't have that. We have it in standard form and we need to convert it to slope-intercept form. If you don't remember how to do this, then please look back at your previous notes. So my first problem, I have 2x plus 2y is equal to 6. I'm going to bring that 2x to the other side of the equal sign by using the opposite operation. Since it's a positive 2x, I'm going to subtract 2x on both sides. 2x minus 2x cancel out, leaving the 2y is equal to negative 2x plus 6. Now, I need to get rid of that 2 in front of the y. Since it's multiplying by y, I need to divide by 2 on all sides. Remember, if that 2 is a negative, you need to divide by a negative as well. And I am left with y equals negative 2 divided by 2 can be canceled out to be negative 1x, or just negative x, plus 3. And the 3 is from 6 divided by 2. So I have one equation in slope-intercept form. Now I'm going to do the same thing with my other equation. I have 4x plus 6y equals 12. I'm going to subtract 4x on both sides to get 6y is equal to negative 4x plus 12. Then I'm going to divide by 6 on all parts to get my final equation of y equals negative 4 divided by 6 can be simplified to negative 2/3 x plus 2. Again, I went through that kind of quickly just because it is something we've already learned. If you do not remember how to do this, please go back into your previous notes. Great. Now step 1 is done. I'm going to move on to step 2. And step two is graphing the lines and identifying where they cross. So where the lines cross, that is that one solution that we're looking for. It is important that when you are graphing that you put dots on every single part of your line. Because if you don't, that can be wrong. So don't just put 3 and put a line, continue with the dots. And I'll show you what I mean right now. So we have our lovely graph here. The first equation that I'm going to graph is y equals negative 1x plus 3. So I'm going to start at my y-intercept at 3. And my slope is negative 1. So that means I'm going to go down 1, right 1, down 1, right 1. And notice how I am putting dots. I am not just drawing the line. If I just draw the line, I can run into problems if it's not completely centered. So I need you to draw the dots so that everything is accurate. So I have all my dots. I am going to connect my line, or connect them with a line, I should say. So see how lovely that line is that I created? It's kind of off, and that's a problem that you can face if you don't do the dots. So this problem right here is y equals negative 1x plus 3. The next one I'm going to do is my next problem, which is y equals negative 2/3 x plus 2. I'm putting a dot at 2, and I'm going to follow my slope, which is negative 2/3. So I'm going to go down 2, right 3, and put a dot. Down 2, right 3. Again, notice how I am doing my dots. If you find your solution, you don't have to really continue with the dots, but I am just doing so that you can see. See how super important it is. Now, if you don't remember how to graph, you need to go back and look at your notes because this is the biggest part of all of this. So notes are always available if need be. And I kind of went by fast through graphing that. So please remember that you cannot or should not go left unless you're doing the opposite. So this equation was the y equals negative 2/3 x plus 2. So I have my 2 lines. Great. Now for the whole point of this is to find that one solution, that one point in where both lines cross. And in this case, where 2 dots are right on top of each other. And that is going to be right here at 3, 0. So my solution to this problem is 3, 0. So to recap what I did, I converted each equation to y equals mx plus b, or to slope-intercept form. I graphed them and noticed where my 2 lines crossed. When graphing, I also made sure to include each and every dot so I can see which point both dots cross. Now there is a couple more things that you should know about this. First off is that you can check your answer. This is step 3. You can check your answer by taking your solution and plugging them back into the equations. So I had my solution of 3, 0. Wherever I saw an x, I plugged in 3. And wherever I saw y, I plugged in 0. If whatever is on the left is equal to whatever on the right, and it's correct, great job. If it's like that for both problems, then you know you did it right. So you can know you have this done before you even turn it in. Another thing that you should know is that there are some special cases. If you have 2 lines when you graph that don't cross at all, or also known as parallel, then there's no solution. There's no point in which they cross, no solution, done. Sometimes you'll also get 2 lines that lie right on top of one another or are the same line, and that's called infinite solutions. It's infinite solution because every single one of these dots will fit in that or those 2 equations. So special cases to look out for. Please, please, please remember to put dots on every part of your graph and to make sure you're checking your work. Go back into previous notes if you need to, but you can definitely do this. Good luck.